Part 2 of section 4.2. You'll see some examples here. Example 1, a city's population grew by 3% per year between the years 2015 and 2019. The number of people in the city in 2019 was 107,834. So using an exponential growth model, how many people were living in the city in 2015? So in a sense, what you're doing here is you're finding the initial amount, because they just say, oh, from 2015, that's where you started recording 3% growth rate. So this is the initial year. So we want the initial amount. How many people living in there? So we're looking for the P0. So let's get some information. First thing I'm going to do is just write down the formula. I like to do that because when you write down a formula, in this case, using the exponential growth model tells me I'm going to use this thing right here. And when you do that, it helps kind of organize your thoughts for one and lets you know what you need to pick out of the statement. So we know we're looking for P0, so I'm not going to worry about that. The R, they gave me that right here, 3%. So R is going to equal 0.03. Remember to move the decimal. It's a very easy mistake to make. I see students do it all the time. And if you don't move that decimal, you're going to get the completely wrong answer. So make sure you always convert your decimal, or I should say your percent, to a decimal to make sure that you get the right answer. And then they told me something that happened in 2019. So note that 2019 minus 2015, what I'm trying to do here is get the number of years, is equal to 4. So really what they've told me here is that the population 4 years after we started measuring this thing was equal to 107,834. So that number I'm going to go ahead and put on the left side. The P0, we're solving for that. So I'm just going to leave it P0. And then 1 plus 0.03. And then the T, that's right here. This is T is 4 that we used to get that 107,000, or what, 4 years later, what we'd see for that population. So you just put the 4 in the power. And now what we can do to solve for this is just do 107,834 divided by, I'm going to go ahead and make this just 1.03, adding the 1 and the 0.03 raised to the 4th power. And then that will give you the P0. So you really just need to divide by this stuff right here because it's being multiplied by the P0. And if you put that in your calculator, what you're going to end up with, or more importantly in the Desmos, is 95,809.11 equals P0. And then you would round this here for the model. So P0 would be approximately 95,809. So that's the number that you'd be looking for. All right. So then in part B, they say let T be the number of years after 2015. So really, in 2015, they're telling you that T equals 0. That was your starting year. And P of T is going to be the population in that year. So when they say this, not the year 2015, but P of T is going to be the population in some generic year, T years after 2015. So that's what they mean by that. And then you're going to use the answer from part A that we got right here, this beautiful result, to create a model for P of T. So I got everything else I need. I got the growth rate, and now I have the initial amount. So I can just plug this in as 95,809 for that P0 in the form. And then I'm going to have 1.03 just to make things a little nicer, and then raised to the T power. So you just use what you found in part A and the formula's general form here, and then plug in the P0 that you found and plug in the R that was given. And now you have a model. I can plug in any T and it'll tell me how many people will be there after so many years. So then using the model, if the growth continues at this rate at 3%, how many people will be living in the city in 2030? Round to the nearest integer. And this is where you have to be careful. Again, I see students make this mistake. I think I alluded to it in the linear stuff. But it's real easy when you're doing these problems and you haven't been paying attention. You plug in 2030. Well, 2030 is 2,300 years beyond 2015 that they set as the starting point. So you're going to get a huge number, and you don't want to do that. So you need to find t, and anytime they're working with time from a certain year, and then they want the years or the population in a certain year, you got to make an adjustment from the years to the time. So we need t, and you're just going to take 2030 and then subtract away the starting year that they indicated as 2015. And when you do that, you get this 15, and this is the t value that you're going to use in that population formula. 2030 is 15 years from the starting amount, and that's where you would get up to 2030. So then you plug in this 15 into the power. Just write everything else down first. And when you work that out, you get 149,267.30. And this is approximately 149,267. So you get your population here, and you just round it nearest integer, and you're done. Okay, so one thing I want to mention, I've kind of gone away from saying things like pause the video to do this example, because I felt like maybe I hopefully trained you early to think about that. But I'm going to bring it back now just to refresh, because I haven't said it in a few videos. But I do expect you with these examples to maybe pause them and try them before I go through them. It's going to give you a much better understanding of what's going on, a better appreciation for what's happening in the example. When you try it, you're like, oh, I'm stuck here. I want to see how he does that. Whereas if you're just watching it like watching TV, it's just going to go right through you, and you're not really going to catch everything. You won't be actively engaged as much. So all these examples, I pretty much expect you to just kind of pause, try them, and then come back. Okay, so on that note, here's example 2. So $5,000 investment was made in some shares of a company's stock. After 5 years, the shares are now worth $24,000. So estimate the growth rate of the stock. Write your answer as a percentage rounded to the nearest integer. So again, we're going to, in this case, use the P of t. Whenever they say, estimate the growth rate as a percentage, you pretty much assume it's going to be exponential, even though they didn't really come right out and say it. But if you're given a percentage growth rate per year, it's going to have exponential. So when they say as a percentage, we can do exactly what we're doing here. So set up that formula. And then what do we have? Well, 5 years is t, so I know, t is 5 years. And really, more importantly, p of 5 is 24,000. They tell me an amount after 5 years. And then a $5,000 investment, that's going to be your P naught. So here's a t value, here's a P of 5, and we got the P naught being 5,000. And I need to know the growth rate. I don't know the rate. But I do have a t. I have something for the left side. I'm just going to go ahead and write that in. I've got the 5,000, and then I can just do 1 plus r raised to the 5th power. So you're trying to solve for r, and r is inside this parentheses. So I'm going to get it alone first by dividing both sides by 5,000. And when you do that, you're going to get 1 plus r to the 5th power. And you can reduce this 24,000 over 5,000 to be 4.8. And then it's like, well, how the heck do you get this thing without that fifth power? Well, you have to undo the fifth power with the fifth root, just like you would undo a square with the square root. So we're going to take this equation and take the fifth root of both sides. And when I do that, the fifth root and the fifth power cancel out. And in Desmos, how do you do a fifth root? So let me show you. Right, in Desmos, you just go over here to this little keyboard on the bottom left, go to Functions, go to Miscellaneous, and right in the middle of Miscellaneous, down in that list, you see this little N with the little root symbol. So we want the fifth root of 4.8. And I'm just using the arrow key to move around after I type that. And we get 1.3685. I'm just going to go out 4 decimals. That should be enough for the accuracy. So coming back over here, we will have this 1.3685 equals 1 plus r. And then I can subtract 1 from each side, and you get 0.3685 equals r. And now they want a percentage rounded to the nearest integer. So this would be 36.85% equals r, or rounded to the nearest integer would be 37%. So that's the answer they're looking for that particular problem. And then moving to part B, if A of t is what the shares are worth at time t, and t is time in years, create a model for the shares worth using the rounded growth rate from part A. So now we're just, putting this together. So A of t, they're using a little different notation. A, P, I see both of them show up. But A of t would just be equal to the 5,000 starting amount, the P naught, times 1.37, because remember this was really a 0.37 if you rounded that, and then raised to the t power. And that would be your general predictive formula there that you could use. So now in part C, assuming the growth rate stays the same, which is a tremendous growth rate, by the way, how many years until the shares will be worth 100,000? So this problem right here, we don't know the t, and this one is going to have a little bit of something you may have never seen before, and maybe you haven't seen any of this before, but this next little piece here is something you may never have seen before, and I want to make sure that I have time to do it without running out of my 15 minutes. So I'm going to pick this up in part 3, and I will show you the function that you need to use in order to solve for this t that's up in the power. Think about that in between videos. How do you solve for a power?